Okay, so let's look at the next one. So we've got express 8 to the power of 2x minus 5 in the form 2 to the power of y, giving y in the form ax plus b, where a and b are constants. Okay, so for this one you have to know your laws of indices again. So 8 to the power of 2x minus 5 is the same as, okay, you can split that up, so it's 8 to the power of 2x multiplied by 8 to the power minus 5. Okay, your laws of indices will tell you that. Okay, that equals that. Okay, if you're going the other way, you could say because they have the same base, in this case 8, therefore you could say 8 to the power of 2x minus 5 simply because they have the same base. If this was 9 or any other number, you couldn't bring it together. Okay, so we want it in the form of 2 to the power of y, so we have to rearrange this somehow. So 2 to the power of what would give you 8? That would be 2 to the power of 3. And you've still got to the power of 2x outside. Okay, hopefully you can see that I haven't changed much here. 2x to the power of 2x still remains, but 8 can be rewritten as 2 to the power of 3, as in 2 times 2 times 2. And we can do the same over here. 2 to the power of 3 inside the bracket, and you've got minus 5 outside. Okay, and then from the laws of indices, power inside the bracket, power outside the bracket, what does that mean? You can multiply them together. So that gives you 3 times 2x would be 6x, multiplied by 2 to the power of 3, all to the power of minus 5. 3 times minus 5 is minus 15. Okay, so it's almost like the opposite to what we did at the start now. Okay, we started off with 8 to the power of 2x minus 5 and split that, so we had 8 twice. Yeah, so because we have the same base here, it's not 8 this time, it's 2, but because it's the same base, we can bring the powers together. So that equals 2 to the power, and if you're multiplying together with the same base, you add. So it's 6x plus minus 15 is the same as 6x minus 15. Okay, so that is in the form 2 to the power of y, where y is ax plus b. In this case, a would be 6 and b would be minus 15. And that's your answer. Okay, right, let's look at the next question. We've got y equals 2 to the power of x. Part A, express 4 to the power of x in terms of y. Okay, so express 4 to the power of x in terms of y, given y equals 2 to the power of x. Right, so you should see that there is going to be a link here. 2 to the power of x, given that y equals 2 to the power of x, express 4 to the power of x in terms of y. Okay, so there's going to be, these two have to be related somehow. So hopefully straight away you can see that you could write that down straight away. 4 equals 2 squared. Okay, one of the most basic squared numbers. And then what would you do next? We've got to express this in terms of y. Okay, so you could just put this to the power of x. Whatever you do to the left hand side, you have to do it to the right hand side because they equal each other. 2 squared to the power of x. Okay, 4 to the power of x equals 2 squared to the power of x. So not much more we can do with the left hand side, but we can manipulate the right hand side. So let's keep going. So we could say 4 to the power of x equals, if you know your laws of indices, if you've got the power inside and power outside, you multiply them. So that's 2x, so that's 2 to the power of 2x. But that's not exactly how we want it here. They've got 2 to the power of x. So I would rearrange that. Okay, so that's 4 to the power of x equals 2 to the power of x 2. Okay, that typically you do put the coefficient before the x, but if we're going to keep it in line with this question, I would leave it like that. I mean, it doesn't matter which order really. 2 times x is the same as x times 2. You know, 2 times 3 is the same as 3 times 2. Okay, but now that it's written like that, hopefully you can see there's a link here. So we've got to express 4 to the power of x in terms of y. We have 4 to the power of x on the left hand side. We've got an expression for y. We've got 2 to the power of x, 2 to the power of x. So if we substitute the value for y in here, so that's effectively y squared. Yeah. So if I take that over here, that's the same as 2 to the power of x squared, if that makes it any easier. Yeah, 2 to the power of x squared. Therefore, you can maybe that's easier to see it. There's a straightforward substitution. The y goes in here. That's where the 2 to the power of x was. That's the same thing, because all you're going to do is multiply them anyway, so that equals that. But if that makes it easier, it's a straightforward substitution. 4 to the power of x equals y squared. Okay? Right, let's keep going. Right, so let's keep going. Part B. Hence or otherwise solve 4 to the power of x minus 6 times 2 to the power of x minus 16 equals 0. So any question that says hence means you're going to use the previous answer, which means we can do a straightforward substitution here. So we can say this equals y squared minus 6y minus 16 equals 0. Okay? Right, so from part A they gave us the value of y. They said y equals 2 to the power of x. So all I've done is just substitute that here, and we also calculated from part A that 4 to the power of x equals y squared. So that's just a straightforward substitution. And from here, it should be straightforward. Okay, you could use the class whiz calculator to calculate this, but it's a fairly straightforward quadratic. You should see that you've got two sets of brackets here, and it would solve like this. You would say y and y. What are the factors of 16 that would give you factors of minus 16 that would give you minus 6? Okay, so that would be minus 8 and plus 2. Double check using FOIL. Y squared minus 8y plus 2y would be minus 6y minus 16. Okay, therefore y equals minus 2 and 8. Okay, but that's not the question finished yet. It says hence or otherwise solve, so you're going to have to find the value for x. So you put it back into what we started with. So it was 2 to the power of x equals minus 2, and 2 to the power of x equals 8. Okay, so you should know from your exponential and logarithm laws that you can't have negative 2 here. That doesn't work. But you can have the positive on the right hand side. You can't have a negative, but you can have a positive. So 2 to the power of x equals 8. Therefore, 2 to the power of 3 equals 8. Okay, that's a fairly straightforward power. 2 times 2 times 2 would give you 8. Therefore, x equals 3. Okay, and that was 5 marks, that question. So in part A we had to express 4 to the power of x in terms of y. That was 2 marks. Part B, even though that was worth 3 marks, I think that was a bit more straightforward. Okay, because once you've just done the substitution, that's just GCSE really. Okay, quadratic, solve for y. This part here, yeah, you had to know some laws, but once you've eliminated this one, 2 to the power of x equals 8, you can see that x would be 3. Okay, right, let's keep going. This is a very common question. So we've got 2 to the power of 2x plus 1 minus 5 times 2 to the power of x minus 12 equals 0. So this might look a bit confusing as well, like a lot of these indices questions. The first time you see it, you think, what on earth? But like a lot of these questions, the more you do, the more straightforward it becomes. So hopefully you start to recognize that this can be solved by using the laws of indices. Okay, so let's just deal with that first. We can come to the rest later, but let's deal with this first of all. So 2 to the power of 2x plus 1, that's the same as 2 to the power of 2x multiplied by 2 to the power of 1. Okay, because they have the same base, again if you go in the other direction, because they have the same base, you can bring it together, so it's going to be 2 and you add the powers together. So it's 2 to the power of 2x plus 1. Remember, if you're multiplying the 2's together, because they have the same base, it becomes 2x plus 1, if you were going in the other direction. And the rest I would just leave just now. There's not much else we can do here. There's a reason they've put 2 to the power of x within the bracket, and you can hopefully see, looking at it, that you're going to try and get 2 to the power of x here and here, okay? Because you want a substitution. That's what this question is leading towards, a substitution. But we can't substitute unless we have the same term here and here, okay? So I would leave the 2 to the power of x here for now and just deal with this first expression. So similar to the last question, we can rearrange this. Yeah, if you see any patterns 2 to the power of x, try and get this first term to be 2 to the power of x. So that can be the same as 2 to the power of x squared. Okay, that equals that. All I've done is just change the order. So I could have put another line in here that said 2 to the power of x 2 and then put the bracket around 2 to the power of x, but that's the same thing. Because if I was to multiply these together, you know, from your laws of indices, power inside the bracket, power outside, that would just give me 2 to the power of x 2, which is the same as 2 to the power of 2x. Okay, a lot of people get confused with that, but that is the same thing as that. Okay, multiplied by 2 to the power of 1 is just 2, and you've got the minus 5 times 2 to the power of x minus 12 equals 0. Okay, so now that it's written like this, okay, we have this term 2 to the power of x that we can substitute, okay, and then it'll be a quadratic that's a lot more straightforward to solve. Okay, so typically the substitution would be 2 to the power of x equals, so you could do a number of things. Some people like to do capital X, but I prefer to do it like 2 to the power of x equals y. I think having a capital X might be misleading when it comes, you know, to solving it later on. You might think, well, I've got a value for x, but you know, that wasn't the initial small x. So substituting a capital X for a small, I'm not too keen on that. I think we should substitute it for y. It's easier to remember that that wasn't what you started with. Okay, so therefore that becomes y squared times 2 minus 5y minus 12 equals 0. So that's effectively 2y squared minus 5y minus 12 equals 0. Okay, so we can solve that now. Okay, so you could solve this on the class whiz calculator. It does have that function to solve quadratics, but it's not a particularly difficult one. Hopefully you can see how to do this one. So 2y squared, the first two terms in the brackets have to be 2y and y. And what are the terms, what are the factors of a negative 12 that would give you minus 5 combined with 2 minus 2y and y? So that would be minus 4. So minus 4 times 2y would be minus 8y plus 3y. So let's double check using FOIL. First terms, 2y times y would be 2y squared. Outside, minus 4 times 2y is minus 8y. Inside is 3y. So minus 8y plus 3y would be minus 5y. Plus 3 times minus 4 would give you minus 12. Therefore, y equals minus 3 over 2 and 4. Okay, so therefore we have 2 to the power of x equals either negative 3 over 2 or 2 to the power of x equals 4. Right, so you should know from your laws of exponentials and logarithms that you can't have a negative here, so that's a no-no, but we can solve this one because it's positive on the right hand side. So you say 2 to the power of x equals 4, therefore 2 to the power of what would give you 4? That's 2 squared. 2 squared equals 4, therefore x is equal to 2. Okay, so that was 5 marks for that question. Quite a lot going on, but you can see here we've got the sort of GCSE standard in the middle of the question. You've got the quadratic and then solving 2 sets of brackets and the 2 values. This part here, it was more to do with the laws of indices. You really need to know these laws because you can't answer the question without them. Okay, so just keep referring back to the laws of indices and the question should just fall into place. Okay, so again, quite a lot going on, but when you break it down, there's nothing there that's too daunting, I don't think. Okay, you just have to practice and then keep going. That's it. For maths tuition, in person or online, you can visit the website at analogos.co.uk. The link is in the description.